Growing up, playing at the highest levels of both youth and varsity soccer, I completely took the sideline medical staff for granted. When a player goes down, a trained professional would be there in just seconds to their aid. However, since moving to UCLA and transitioning to a more rigorous bioengineering track, those hard and rough games transitioned to more friendly pickup and intramural style games, just like that going on behind me. As a result, that safety net vanished. Now, when a player goes down, there are no doctors, no medical professionals, just a group of college students using their flawed personal judgment to diagnose a potential traumatic brain injury. This disparity is statistically even more dangerous for women who suffer significantly more concussion rates when compared to men. Hi, my name is Fawad Haddad. I'm a second-year bioengineering student here at UCLA, and I want to engineer a solution that brings hospital-grade point-of-care diagnostics, just like this, to the sidelines. You could think of your brain cells as a bunch of small, tiny, and fragile water balloons. A hard hit on the field might pop these water balloons, thus leaking specific neurological proteins that are normally locked away behind the cell's membrane into the brain's interstitial fluid. To detect a concussion, we could set our target biomarker to be a specific protein called GFAP. Paper-based point-of-care diagnostics, just like the over-the-counter pregnancy test, utilize the Lateral Flow Assay, or LFA for short, which is engineered to capture your target biomarker. In our case, the GFAP protein in saliva. Imagine inside the strip a bunch of microscopic security guards called antibodies, who are scientifically programmed to look for and only capture our GFAP protein. When you place a saliva sample on the pad, it travels down the strip through capillary flow. If you are concussed, those leaked GFAP proteins are caught by our security guards. As they clump together at the test line, a colorimetric line will appear. It's a visual X that tells us, hey, stop, we found a trauma marker. However, if you're not concussed, there's no GFAP to catch. The saliva flows straight past the test line and will stay blank, meaning you're clear. It's a quantitative, the deeper the color of the line, the higher the concentration of the concussion biomarker. Now you might be thinking, hey, why can't we just use these tests immediately after when a player goes down on the field? Well, the truth is, human biology just doesn't work that fast. When your brain cells pop following a collision on the field, it takes time for those GFAP proteins to cross the blood-brain barrier and enter your saliva. As a result, administering these tests immediately on the sidelines might lead you to miss your target biomarker, leading to false results. Furthermore, clinical accuracy requires more than one test to be administered. Extreme acute exercise could alter the blood-brain barrier permeability, thus triggering inflammatory proteins to pass, which could lead to false positives. While this innovation cannot be used for a rapid response test to determine if a player gets concussed, we can use this innovation to create a return-to-play concussion clearance tracker. To achieve true diagnostic specificity, we pair the paper test with the computer vision smartphone app. Instead of guessing, athletes can scan their tests daily. The app's algorithm quantifies the biomarker concentration right there on the device, plotting the degradation curve over time to distinguish between a brief exercise spike and a true concussion. When the athlete's data returns to a physiological baseline, the app autonomously generates a data-driven, clear-to-play notification. However, recovery shouldn't happen in a vacuum. This critical health data needs a secure and reliable path to sync to cloud data warehouses in real time. AT&T's world-class network of cellular and fiber optics is the perfect fit for this requirement. This ensures that while the athlete gets an immediate answer in their pocket, a verifiable medical log is instantly available to be shared with a remote physician, a team coach, or a parent anywhere in the world. We are taking the guesswork out of recovery while keeping the medical power entirely in the player's hands. The goal here isn't just to pitch a concept, it's about democratizing sports safety. Right now, my lab research is focused on taking these exact type of biosensors, just like the GFAP protein, from the lab bench into the real world. By pairing a bioengineered LFA with a smartphone and the AT&T cellular network, we could take world-class concussion tracking and put it into the pocket of every amateur athlete. I want to build a future where a player's safety doesn't depend on the budget of their team, but rather the science we carry in our pockets, protecting the cognitive health of every amateur athlete everywhere. Thank you.